everyone, myself Sravanthi, working as Assistant Professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is Shift Reduce Parser or SR Parser. So here we are going to discuss what is Shift Reduce Parser, what is the definition and what are the steps we are going to follow and what is the example of Shift Reduce Parser and what are the conflicts that are occur in Shift Reduce Parser. So all these things are discussed here in this topic. So what is Shift Reduce Parsing? So the name itself tells us that there are two data structures. It follows two data structures, that is nothing but shift and reduce parsing. Okay, so here to do this, we are going to have the two data structures we are going to follow. The two data structures are, it is nothing but stack and the input. The stack and input are the two data structures that are used to hold the input string. A string is reduced to the start symbol. A string is reduced to the start symbol. It is a process of reducing a string to the start symbol of a grammar. To do this, to reduce the string to the start symbol, we are going to use two data structures, that is nothing but the stack and the input tape. Stack is used to hold the symbols and input tape is used to hold the input string. Input tape is used to hold the input string. As it is a bottom-up parser, we are going to take the input string and we are going to generate start symbol. So that is why we are going to generate start symbol. We are going to follow shift and reduce actions are going to be allowed. It performs two actions, shift and reduce. That is why we are going to call it as shift reduce parsing. At the shift, the current symbol in the input string is pushed onto the top of the stack. At each reduction, the symbol will be replaced by the left side non-terminal. So nothing but here, shift is nothing but if I find any substring or if I handle the substring from the given grammar, from the given production, replace that production with the left side non-terminal. Nothing but we are going to replace is nothing but reduce. Shift is nothing but we are going to move the substring to the stack. That is nothing but shift. We are shifting from one to another one. Basic operations. There are four actions that are going to be take place here. Shift, reduce, accept and error. So we can also call it as operations. This is nothing but shift is nothing but we are going to move the symbols from the input buffer onto the stack, and reduce is nothing but if any handle or if any replacement of the production is there, we are going to apply the reduce action. Nothing but RHS of a production is popped out of a stack and LHS of a production rule is pushed onto the stack. Nothing but if I move these ID onto the top of the stack, if I find these ID in my grammar, nothing but in my production, for example, E tends to ID. If I find these ID in the production, then replace these RHS with LHS. Nothing but pop this one and push E onto the stack. Accept. If only the start symbol is present in the stack and the input buffer is $, nothing but the parsing action is accepted. When accepted, it means that the parsing is done successfully. There are no syntactical errors. The token is correct. If and error is nothing but if any unexpected or invalid inputs, nothing but when I cannot apply shift action or reduce action, then it is nothing but the given string is having some errors. So nothing but at that time we are going to find the error. Let us see one example. E plus T, T star F and E ID. So this is my input string. So let me construct the parsing table. So to construct the parsing table, we are going to have three columns. The first one is stack. It is used to hold the actions, and input, nothing but the given input string we are going to place. Action, nothing but what type of action we are going to apply on the input string. So let me take the input string as ID into ID $. So initially the stack is holding $. It indicates that it is my top of the stack. And the input is ending with the $. It indicates that my string is completed. So when I find the $, at the end of the string, it indicates that, okay, I completed reading my string. Now initially $, the top of the stack, and input is ID into ID $. Now what I am going to do? I am going to shift these ID onto the top of the stack. So now what type of operation I have done? Shift operation. Nothing but I am shifting ID from input string to the stack. Now what we are going to do is we are going to check or we are going to handle if any substring which is there in the stack can be handled by using these productions. Nothing but if I find ID in the production RHS, then I can replace that ID with the LHS non-terminal, replacing of that production. Let me check ID. Yes, I am finding ID. So I can replace ID with F. So nothing but we are going to apply reduce F tends to ID. Now ID is replaced with F. ID is replaced with F. Now let me check. Still F can be reduced. F can be reduced. Yes, I can reduce F to the T. I can reduce F to the T. Reduce T tends to F. Which production? T tends to F. So the same production we are going to apply. F is reduced with the LHS non-terminal. F is reduced with T. Next, T can be reduced. Yes, I can reduce T to E. I can reduce T to E. But if I reduce T to E, for example, let us assume if I reduce T to E, then the next input string what I am having E is star I am having. The next what I have ID. ID I am going to move. So ID can be replaced with what I can replace F or T something. But can I find E star in my production? I cannot find E star in my production. I cannot find E star. After E there is a plus sign but there is no star sign. So nothing but if I reduce T to E, then there occurs some conflicts are going to be occurred. So that is the reason based on the productions, still I can reduce. If there is, still there is an option to reduce the string, but we need to check whether I get further the production can be reduced. Nothing but whether still I can handle or still I can replace the productions or not, we need to check. So if I have here T, I am reducing T to E. But E, the next symbol what I am having star. E star I cannot find in my whole production. I cannot find whole production. I cannot find E star. So that is the reason I am not going to replace E star. E star is not reduced. Okay. So now T. The next what I am having star. So we are going to shift from input to the star. So that's why we apply shift operation. T star. Okay. Next ID dollar. So T star, any operation is there, any productions are there with T star? There is no productions. So we are going to shift ID to the stack. Shift ID to the stack. So T star ID. ID can be replaced. Yes, ID can be replaced with F. ID can be replaced with F. Nothing but reduce F tends to ID. So ID is replaced with F. Star dollar T star F. Next, F can be reduced. But F can be reduced. Let me check T star F. Can I find here in the production? Yes, T star F can be reduced to T. Reduce T tends to T star F. So T, this whole is reduced to T. Next, anything is there in the input, it is completed. So when we tell the string is accepted, when I reach the start symbol. So T can be reduced to E. So T can be reduced to E. So reduce E tends to T. So I am having in the stack dollar start symbol and I have completed reading my input string. I am having dollar. So nothing but we can tell that the string is accepted. So this is nothing but shift reduce action. Shift reduce passing table. So we have one more example. S tends to S plus S, S star S and ID. S plus S, S star S, ID. ID plus ID plus ID. Okay. So now what is the input string? ID plus ID plus ID dollar. And my top of the stack is dollar. So what we are going to do first is nothing but we are going to shift ID here. Dollar ID. ID can be reduced. Yes, I can reduce to S. Reduce S tends to ID. It is reduced. Now next what I have plus. S plus. Nothing but shifting S plus. So S plus anything is there? No. So still I need to shift. ID is shifted. So what I am having here ID. ID can be reduced. Reduce S tends to ID. S plus S. Can I find S plus S in the RHS production? Yes. It can be replaced with yes. S. It is replaced with yes. Now next what I have plus. So shift plus. Next what I have ID. Shift. Shift S plus ID. Now ID can be replaced with yes. So nothing but reduce. Reduce S plus ID. S plus S. So nothing but S plus S is nothing but I can reduce it to yes. Start symbol. So I find here in this stack dollar and here in the input buffer dollar, nothing but I can tell the string is accepted. Here in the stack I have start symbol, and in the input buffer I have completed reading my whole string. So how I came to know that I have completed reading whole string? Just because of this dollar. So then we can tell that this string is accepted. So there are some conflicts that are occurred in parsing. So when we construct the parsing table for LR of 0 or LILR of 1, SLR of 1 or CLR of 1 parsing, we are going to find some conflicts. So in the process of parsing stage where there is a problem in deciding the production to be used, so nothing but we are going to call it as conflict. When we are going to have some table, here we are going to find shift action as well as reduce action. When both the things are found, then I don't know that whether I need to shift or whether I need to reduce. So this is nothing but when both the actions are taking place, then this is nothing but we are going to call it as conflict. Okay, so there are two kinds of conflicts are possible. Shift reduce conflict, reduce conflict. These are the two conflicts. See here in this example, I have told you T can be reduced to E. But if I reduce it to E, then there is a conflict. That what is the conflict? I cannot find E star in my string. And reduce, nothing but I can reduce. So whether I need to shift or whether I need to reduce. So this is nothing but the conflict. This is nothing but the conflict. Whether I need to apply shift operation here, nothing but whether I need to replace with a T star or whether I need to reduce T to E. So nothing but here I have two options like to shift and to reduce. So which operation should be done is don't know. So that is nothing but the conflict. Based on my input string, based on my grammar, we are going to apply this is nothing but shift reduce conflict. For example, the same ID is present over here also. Now, these ID can be replaced with F or ID can be replaced with T. Nothing but reduce conflict. So I'm finding ID in F and I'm finding ID in T. So which one I need to reduce? Which one I need to apply? Nothing but reduce conflict and shift reduce conflict. These are the two conflicts possible. So these conflicts are occur in the parsing, LR parsing algorithm. There are 4 types of parsing algorithms: LR of 0, LALR of 1, CLR, SLR. So there you will find these conflicts. Consider the symbol stack. Suppose X equal to $F. Now their input string points to star. Now there also exists T star F. Now whether what I need to do, we can shift there by $F star or I can replace F to T. Now same thing which we have seen. Here these F I can replace it with T. Nothing but replacing is nothing but what I am going to do, reduce, or I can shift star. So nothing but shift operation and reduce. Nothing but there are two operations are showing. So which one I need to do? So that is nothing but it's a conflict for me. So this is nothing but this condition is referred to as shift reduce conflict. The next one is reduce conflict. Suppose for me I am having the symbol stack X equal to $MAAB. Now let's say there exist two productions which give rise to AAB. Y is having the same thing, X is having the same thing. So which one I need to handle to replace this one? To replace this one, which one I need to handle? Which one I need to handle? Whether I need to replace it with Y or whether I need to replace it with X. So nothing but replacing is nothing but reducing. So when I find the same substring in two productions, then I don't know which one I need to apply. So that is nothing but that conflict we are going to call it as reduce conflict. Next. So what are the resolutions we are going to do for these conflicts? Nothing but basically these conflicts are occurred in these parsing techniques. So these we are going to remove by using the parsers. So based on our input string, based on the given production, we are going to apply we are going to reduce the shift reduce conflict and reduce conflicts. So this is nothing but about the shift reduce parsing. So what is shift reduce parsing? What are the actions that takes place in shift reduce parsing? And what is the parsing table? When we tell the string is accepted, when we find the conflicts. In the given example, we have seen one conflict in the example. So if I apply shift reduce conflict, there occurs. So based on my input string and based on the given grammar, we are going to apply and we are going to overcome the shift reduce conflict. And we have seen how the conflicts are going to occur. Thank you.